In this question, we've got two boxes, P and Q, and they're connected by a light inextensible rope which passes over a smooth fixed pulley of B. And you've got a different incline on each side here. So you can see here that P, which has a mass of 3, it's on an incline at 40 degrees, and Q, which has a mass of 5, is an incline of 60 degrees. Now, in this question, it says the coefficient of friction between P and the plane is 0.3. I'm just going to write that in. So mu on this side is 0.3, and on this side it says the coefficient of friction between Q and the plane is 0.1. Now this makes this question a wee bit easier because you know then you've defined in the latter part of this question, you've defined the acceleration of the whole system, but you'll know because first of all this is a heavier thing, this box Q is heavier than P, and also it's a bigger angle, so it's steeper, but also the coefficient of friction is less, so there's going to be proportionally there's going to be less friction on Q than there is on P. So it means it's definitely going to move down this direction. It's going to just move up this way, and it's going to move down this way. So we can mark that on as well. Right, we're going to mark on our normal reactions. I'm going to call this one R1, call this one R2. And your friction then, you're going to have a wee tension here, and you're going to have a tension going this way. Your acceleration is going to be going this way, and it's going to be going this way. Remember, double-headed arrow for acceleration. And what else have we got? We're going to have our mu's, our frictional force, I should say. So for our frictional force, you're going to have, because it's going to be moving, you're going to have 0.3 times R1, and also this way here, I'm going to change my tension here, get rid of it a wee second just to move it out of the way. Right, I'm also going to have my frictional force here, which is going to be 0.1 times my R2, and then I'll put my tension back in. There is my tension. Now that's what we've got, and then we're going to have to figure out how we do this question. Okay, find the tension in the rope and the acceleration of P. The acceleration of P means the acceleration of the whole system. Okay, we're going to do this in the weird order. We're going to find the acceleration first. So for part 2, we're going to say the whole system Okay, so if we look at this system, I'm going to mark this in green, and this is not to be marked in yours. This is just for me to explain this. So what the force is getting this going is actually the component of the weight of the 5G box going down this slope. So that's a 5 kilogram box. So 5G times, and what I will mark on, and what you should mark on as well, is this wee angle here. If you mark on, you've got, oops, that should be going vertically. If you've got, do your 5G going down here, this angle is going to be 60 degrees, which means this is going to be 5G. You don't have the angle going down this way, so you use sine. 5G sine 60. Okay, likewise over here, we'll mark on our 3G going vertically down. Mark on this wee angle in here would be 40 degrees. So the component of this, and this will be going against motion, this would be 3G sine 40. So if you look at this whole system, 5G sine 60 is what's getting me going. Going against that is 0.1 R2. You've also got T going against it, but going for it is T, so we can ignore that. Then going against it, you've got 0.3 R1, and you've got 0.3 sine 40. Okay, so there's only really one thing going for it, for the system going forward, and everything else, the 0.1 R2, the 0.3 R1, and the 3G sine 40 are all going against it. So I'm going to make a guess at the moment that I don't think this thing is going to be accelerating at any great rate. So we're going to go with this. So let me just write this all in. So we're going to use F equals ma, force equals mass times acceleration. And my force that was getting me going was 5G sine 60. Going against that was 0.1 R, 0.1 R2, 0.1 R2, so that's going to be 0.1 I'll just write it in as that, times R2, and then minus, I've also got a 0.3 R1, and then also I've got that 3g sine 40, and that equals my total mass, which is just 3 plus 5, so it's 8, times my acceleration. So you can see everything here, well, you'll see in a wee second. I can get my R2 very easily. R2 is just going to be equal to, so resolving perpendicular to your plane, R2 is going to be equal to, so let me just do this way with the highlighter here. I've got my R2 going this way, and going this way, I would have, 5g cos 60. So R2 equals 5g cos 60. Same idea. My R1 is just going to be equal to 3g cos 40. So we can just sub those in now. So let's just add all of that in. It's going to be. So let's just say what they were then. So we'll just say we had your R1 first of all. It was equal to. It was going to be 3g cos 40. And your R2, it was going to be equal to 5g cos 60. So that's what we had. So this whole thing then, we can sub those in. And see what we get. So you're just going to get 5g sine 60 minus 0.1 times my 5g cos 60 minus 0.3 times my R1, which we've now worked out as 3g cos 40 minus the 3g sine 40, and that equals 8a. So a lot of work to do here to fire this into the calculator. So do this in one go. Do 5 times 9.8 times sine of 60, and then minus 0.1 times 5 times 9.8 times cos of 60 minus 0.3 times 3 times 9.8 times cos of 40, and then minus 3 times 9.8 times sine of 40, close up bracket, press equals, and thankfully I got something positive, so not a particularly big number, 14.330777707, just put the whole thing down there, equals 8a. A then, just on your calculator, just divide your answer by 8, and what I got to 2 decimal places is 1.79 meters per second squared to 2 decimal places. But I think I would do a few more here just because I'm going to have to use this for the next part of the question. So we'll do 1.791347, but then we'll just put it equal to 1.79 meters per second squared to 2 decimal places. So we've got that written down, but we're going to use this one for the next part of the question. Okay, the last part of the question asked me to say, it says, find the tension in the rope. So I'm going to use this one here. I'm going to use the 3 kilograms. So if you look at the 3 kilograms, what you've got going up, the only force really that's acting directly on the 3 kilograms is this T. So T is the force going up. Going down, you've got the 0.1 R1, and you've got the 3g sine 40. And that equals my mass, which is 3 times my acceleration, which we've now just worked out. So we'll just go back. We'll go back on our diagram. And we'll see back down here. And we'll see how we get this. Oh dear. Right. So just say at the 3 kilograms, we're going to use force equals mass times acceleration. Tension was the only thing getting me going. And then what I had going against that was I had my 0.3 times 3g cos 40. I also had the 3g sine 40, and that was equal to my mass. My mass, remember, is just 3 this time, times my acceleration, which is 1.791347. And I've got that on my calculator still, so just do that right-hand side first. So that times 3. That right-hand side becomes 5.37 0.4041. Okay, and then over here I just have my t minus that. I'm just gonna here, I'll just leave it as this. Don't need to even do it out on my calculator, save me a wee bit of time. And then bring that across then. You're going to have your t is equal to the 5.374041, which I've got in my calculator, plus 0.3 times 3g cos 40, and plus this time 3g sine 40. So we just add those two things on, so plus 0.3 times 3 times 9.8 times cos of 40, and then plus 3 times 9.8 times sine of 40, and that works out that my tension is 31.03 newtons, and that's the 2 decimal places.